for chapter 6. Okay, can you guys see it?
Yes.
Okay, let's get started. Chapter 6 and chapter 7 contains a lot of chemical calculations. Okay, a lot of chemical calculations. So the best way of doing these two chapters is please practice a lot using the examples from these two chapters and from your homework questions. Okay, again, most of the calculations, I need to see your work. And most important part of the calculation is your work. Even your final answer is wrong, you only lose 10% or less than 10% of the credit. The most important part is I need to see your work. Okay, so let's get started for chapter 6 about chemical calculations. And this is the chapter guideline. And we're gonna cover all of it. Let's start with a concept I think most of you have never heard of. I mean, some of you have taken chemistry, some of you not, but I think most of you have never heard of this concept, which is the key of chemical calculations. And the concept is called the mole. Okay, the mole spells M-O-L-E. 1 mole in chemistry is defined as 6.02 times 10 to the 23rd. This is a huge number. Okay, this is a huge number. 6.02 times 10 to the 23rd. Now, the best way of understanding the mole is first, the mole is a unit or a term specifying numbers. Why do I say that? Because 1 mole equals to 6.02 times 10 to the 23rd. 1 mole of anything equals to 6.02 times 10 to the 23rd of anything. 1 mole of balls equals to 6.02 times 10 to the 23rd of balls. 1 mole of atoms equals to 6.02 times 10 to the 23rd of atoms. So the best way of understanding mole is, keeping that in mind, mole is nothing but a number. It's just now a large number. How large? 6.02 times 10 to the 23rd. Now, another way of helping you understanding the concept of mole is think about a number you use in your daily life, a dozen. And everybody know what is a dozen is. A dozen is 12. But if somebody asks you, can you tell me what unit a dozen is? A dozen is the same as a mole, a unit of number. The difference is a dozen is only 12. A mole is 6.02 times 10 to the 23rd. Now, you may wonder, where do we get this number? How can we have this 6.02 times 10 to the 23rd number? This number was actually defined by the number of carbon-12 atoms in 12 grams of carbon-12. First, let's take a look. What is carbon-12? We're learning chapter 2 and 3, or 2, I forgot 2 or 3. Carbon has 3 isotopes, but the isotope with 6 protons and 6 neutrons, the mass number will be 12. That carbon is used as a standard in chemistry. If we have 12 grams of that carbon-12, if we weigh 12 grams of that carbon-12 isotope, then if we happen to be able to count the number of atoms in that many carbon-12, then the number happened to be 6.02 times 10 to the 23rd of carbon. So that's how we get the number mole from. 1 mole equals to the number of carbon-12 in 12 grams of carbon-12. Again, if I have 12 grams of carbon-12, a bag of carbon-12, if I can count the carbon numbers in it, that number is 6.02 times 10 to the 23rd. Some books use 6.022. I mean, for us, 6.02 is sufficient. And that's where we got this number. And by the way, that number is called Avogadro's number. Does it make sense, guys, everyone? The mole, and how do we get the mole?
Yes.
Now, because 1 mole equals to 6.02 times 10 to the 23rd. That's an equivalence. And if you still remember in earlier chapters when we talk about conversion factors, if we have a equivalence, we can create two conversion factors. 1 mole over 6.02 times 10 to the 23rd, or 6.02 times 10 to the 23rd over 1 mole. These are the two conversion factors that can be created from the equivalence. 1 mole equals to 6.02 times 10 to the 23rd. And we will use that conversion factors in a few minutes. Here, concept check. How many eggs does 1 mole of egg contains? Guys?
Is it B?
B, 6.02 times 10 to the 23rd eggs. Again, 1 mole of anything equals to 6.02 times 10. Doesn't have to be atom. Of course, for this big number, we mostly use in atoms or molecules. Next. The reason mole is the key of chemical calculation is because it is related to the mass of atoms or molecules. If you think about it, mole is defined by 1 mole is defined by this many of carbon 12, and the mass of the carbon 12 we use is 12 grams. That's how we define. Again, take a look. 1 mole, 6.02 times 10 to the 23rd. And how do we get the 1 mole? It is actually 12 grams of carbon 12. You can see that carbon 12, 12 grams. And because that's how we define 1 mole, then we can easily figure out the mass of 1 mole of any atom. Because 1 mole of carbon 12 is 12 grams. Then 1 mole of atoms of any atom equal to, in grams, the mass, I'm sorry, let me rephrase. 1 mole of carbon 12 is 12 grams. That means the mass of 1 mole of any atom in grams will numerically equal to the atomic mass. For example, nitrogen from the periodic table, you will find out nitrogen, the atomic mass is 14.01. Then 1 mole of nitrogen, the mass will be 14.01 grams. And the unit will be gram per mole. Why? Because that's the mass of 1 mole of nitrogen. If you look at the periodic table, aluminum, the atomic mass of aluminum is 26.98. We can use 27 if you want. Then 1 mole of aluminum, the mass will be 26.98 grams. Again, think about how we get this mathematical relationship. Carbon 12, this is the atomic mass, no unit. But 1 mole of it is 12 grams. So nitrogen, if you look in the periodic table again, nitrogen in that square, nitrogen, the atomic mass is 14, no unit. But 1 mole of it will be 14 grams. Aluminum, if you look at the periodic table, the atomic mass is 27, again, 26.98. No unit. But if 1 mole of aluminum, then the mass will be 26.98 grams. So we call the mass in grams of 1 mole of something the molar mass. Molar mass means the mass per mole. How do we get molar mass? Equals to the atomic mass for atoms. How do we get atomic mass for atoms? Check your periodic table. Does it make sense, everyone?
Yes.
Okay, remember for atoms, now we're talking about atoms. Look at the periodic table. The periodic table will tell you what is the atomic mass. 14, 12, 16, doesn't matter. But if I ask you how many grams of that atom of 1 mole of it, the mass will be the same number, but in grams. Okay, but in grams, because that's how we define 1 mole. That's why it is useful. Okay, that's why it is useful. Now here, this picture shows you one more of these guys. One more of copper, one more of zinc, one more mercury. I mean, we can't weigh it, but you can see how much one mole is approximately is. Depends on what we're talking about. For example, copper. If you look in the periodic table, copper is 63.5. Then 1 mole of copper will be 63.5 grams. So that means here, the copper will be 63.5 grams if you weigh it. And the same sulfur, if you look in the periodic table, 32. Then that means this much sulfur is 32 grams because that's 1 mole. Okay, so let's move on. This concept not only can be applied for atoms, it also can be applied to molecules because molecules are made of atoms. So if we add the atomic mass of all the atoms in the molecule together, that number we get is called the formula mass. First, if you have a formula like CO2, CO2 means what? 1 carbon, 2 oxygen. If we add the atomic mass together, 1 carbon, 12, oxygen, 16, 2 of it, 2 times 16. So I got 44. That mass is called the formula mass. It doesn't have a unit. If you want, you can use EMU. Again, it doesn't need to be the EMU. It doesn't have a unit. But 44 is the sum of all the atomic mass in that molecule. Again, 1 carbon, 2 oxygen. That's mass of the molecule, but that mass is called a formula mass. It came from the formula. But because we have the mole concept, we can apply the same idea on this molecule. That is 1 mole of CO2 will have the mass of 44 grams. Why? Because we use the same concept. 1 nitrogen, 14. 1 mole of nitrogen, 14 grams. 1 CO2, 44. 1 mole of CO2, 44 grams. Why? Because molecules are made of atoms. If atoms can apply this concept, molecule the same because they're adding together. So that means, in the summary, guys, no matter we're talking about atoms or molecules, the mass of 1 mole in grams will numerically equal to either the atomic mass, if you're talking about the atom, or the formula mass, if we're talking about a molecule. Depends. Again, atomic mass, formula mass, no unit. That's how you got it from the periodic table. But if I ask you the 1 mole of something, the mass will be in grams, but the numbers should be equal. Again, nitrogen, 14 from the periodic table, no unit. 1 mole of it, 14 grams. CO2, we calculated 1 C, 2 oxygen. Formula mass is 44, no unit. Sometimes you will see AMU, but 1 mole of CO2 is 44 grams, and we call that mass as well, again, molar mass. The unit for molar mass is gram per mole. Per mole means what? 1 mole, how many grams? 1 mole, how many grams? 1 mole nitrogen, 14 grams. 1 mole CO2, 44 grams. Does it make sense, everyone? This is the beginning of this chapter. You have to understand everything before we can move on. If not, please let me know.
So you said atomic mass, and what was the other one?
Formula mass.
Okay, thanks.
Atomic mass is talking about atoms like nitrogen, like aluminum. Formula mass, we're talking about compounds, molecules like CO2. Any other questions? Anything, guys? Please understand the concept. How do we get the mass in grams? Numerically equal to either atomic mass or formula mass. Depends whether you're talking about an atom or a formula or a molecule. Does it make sense, everyone?
Yes.
Quick question. What is the molar mass of sulfuric acid? H2SO4. The question I want to ask Becca, can you tell me what is the molar mass of H2SO4?
I got 98.09.
98.09. And what's the unit? Remember,
Would it be AMU?
No, if it is AMU, that's not called a molar mass. That's called formula mass. AMU is the same as no unit. What is molar mass? Take a look. What is molar mass? Molar mass is the mass of what? Take a look.
It was just grams.
Grams. Molar mass, the mass of 1 mole. You got 98.09 is from the molecule.
Mhm.
That number 98 is called formula mass. But
Okay.
if you're asked about molar mass, means the mass of 1 mole. So the mass should be what? Grams per
Mole.
Does it make sense, guys?
Yeah, it makes sense.
Anybody needs help of how she got 98? Anybody needs help? This guy has 2 hydrogen, 1 sulfur, 4 oxygen. You add them together, you get 98. But again, that mass, 98, AMU or not, is called the formula mass. Formula mass is what? From the formula H2SO4. But if we're asking molar mass, guys, if you miss this one, you got 0. If I ask you this simple question, probably not. But if I ask you a simple question, molar mass means the mass of 1 mole. So should be in grams. So the mass will be grams per mole. Per mole means, again, 1 mole of this guy will be 98 grams. How do we get 98? Formula mass. Numerically, they're equal. Very good. Next, what is the mass of 1 mole of aspirin? This question goes to Maxine. Guys have a calculator with you, okay? You know I told you this chapter is all about the calculations. 1 mole of aspirin, Maxine?
It would be C, right?
Right? I'm asking you.
Yeah.
Yes, you're right. You don't ask me, right? C, you're right. Okay, 180 grams. Where do we get 180? Because the formula mass is 180. So 1 mole of it is 180 grams per mole. Very good. Okay, very good. So the aspirin. Again, guys, I think by this sport practice, you guys have idea about what is molar mass and what is 1 mole. Okay, we have introduced what is 1 mole. 1 mole is 6.02 times 10 to the 23rd of that many things. Then 1 mole of something, the mass of it will be in grams, numerically equal to what? Equal to the formula mass or atomic mass if we're talking about atoms. Now, next, let's take a look at calculations. Because molar mass is in a unit of grams per mole. Again, what does mean grams per mole? Grams per mole means 1 mole, how many grams? Think about it. 1 mole, how many grams? That means I have an equivalence. 1 mole of something, I have how many grams? For example, this guy, aspirin, let's use it. Aspirin is 180 grams per mole. Means what? Means 1 mole of aspirin is actually 180 grams of aspirin. Does it make sense, guys? Everyone?
Yes.
And because of that, I have an equivalence. 1 mole and how many grams? I can create conversion factors. And that conversion factors will help us to convert between moles or grams to moles because they're related. If I give you anything, grams and mole are related because molar mass. What is a molar mass? Again, grams per mole. Grams per mole relates these 2 units. gram and mole. That means no matter which unit they gave you, you can convert it to another. So let's take a look. The first very simple calculation. Simple, I means by the end of this chapter, all of you should think this is simple, not now. Okay, first, calculate the mass in grams of 2.5 moles of ethane. The formula is C2H6. First, if I give you a formula, calculate the formula mass first, because we're talking about mass in grams. Then you have to know the formula mass. C2H6, formula mass is 30. That means C2H6, the molar mass is 30 grams per mole. 30 grams per mole means I create two conversion factors, 30 grams over 1 mole over 30 grams. Two conversion factors. Do you guys remember how do we convert the conversion factors? We did that in chapter 1 and 2. I told you chemistry calculation is all about conversion factors. Now, if somebody still remembers, in chemistry calculations, what do we start? Once we have conversion factor, what do we start with? Anybody remember in chapter 1 and 2? If fine, if you don't, but anybody remember?
You would multiply it times another conversion factor?
We use what? We use the given 2.5 mole. Again, you were given 2.4. Always multiply by what? One of the conversion factors. Which one do I choose? I choose the one with mole at the bottom, so I can cancel the moles to get what? I can cancel the moles to get grams. So this is the calculation. 2.5 times 30 grams per mole. Mole and the bottom. So mole and mole canceled. I got 2.5 times 30. This is your calculator. Grams. And the answer will be 7.5 times 10 to the second grams. 266. Does it make sense, guys?
Yes.
Okay, remember, in chemical calculations, I said, you always start with the given, multiply by something. That something is from a conversion factor. How do we get conversion factor? And equivalence. You always will know equivalence. Okay, let's try another one. Calculate the number of moles in 50 grams of water. Water, formula mass 18. So that means the molar mass is 18 grams per mole. So I have two conversion factors, 18 grams per mole or 1 mole over 18 grams. I do the same, start with the given 50 grams times, can anybody tell me what do I need to multiply with?
1 mole over 18 grams.
1 mole over 18 grams. Very good. Where do we get 1 mole over 18 grams? From the molar mass, guys. Why do I put grams in the bottom? Because I want to cancel grams to get moles. So grams canceled. 50.0 divided by 18. Now my unit will be mole. Okay. Let me see. 50 divided by 18. So 2.78 moles. Take a look at these two exercises, guys. Please ask me questions before I move on. Again, like I said, this question will be a very simple one by the end of this chapter. So make sure you completely understand the simple ones so we can move a little higher, step up.
I have a question. So I got 18.02. Are you
That's okay. That's okay.
Okay.
Either way.
Okay, I didn't know if you were converting it just because the sig figs or.
No, the formula mass, because you're doing that from from the periodic table. If you get 18.02, the suffix is still based on the given, because that's
Okay.
from the periodic table. We don't even use that for affecting suffix. So normally water I use 18, but 18.02, that's the same.
Okay.
Yes.
So we are applying sig figs to this?
Yes,
or-
yes,
Okay.
yes. Anybody?
So the amount of moles for H2O is 2 hydrogen and 1 oxygen. Is that right?
What do you mean?
Like for 18, that's how you got 18, right? The-
Yes, that's how to make 18. That's called formula mass.
Okay. Just wanna make sure.
Two hydrogen, one oxygen. That's how you get 18. Then that 18 will tell us 1 mole of it is 18 grams.
Okay. Thank you.
Yes, yes. All right. Anything, guys? Okay, this is a little question related to the concept of mole. Take a look, see anybody can give me the answer. I mean, you don't even need to calculate it if you know the concept, but we could do the calculation. Anyone? One atom of copper. Anyone?
A.
A?
Yeah.
How did you get that?
Oh, is the atomic mass.
Atomic mass has no unit.
Oh.
That's A is in grams,
Oh,
right?
yeah.
Atomic mass 63.55. I agree, you got it from periodic table, but that one has no unit.
Okay.
So you cannot just add a gram after it because that number has no unit. We're asking the mass of one copper atom in grams. So definitely not an A, because that A again has no unit. You cannot just change it one with no unit to a unit without changing anything. Now let me ask you, since we started with 63.55, you got it from the periodic table. That mass has no unit, but if I want to ask you 63.55 grams, if I do want to add a gram after it, we're talking about how many copper? Guys?
One
How many?
mole?
1 mole of copper. So that's what we're talking about. You cannot just simply add a gram. This many copper is 1 mole of it. Now, I want to know 1 copper. This is 1 mole of copper. So we want to know how many is 1 mole. Guys, how many is 1 mole?
6.02 times 10 to the
Very
23.
good. So 1 mole is 6.02 times 10 to the 23rd of copper. Take a look. Why I multiply this? Why I multiply this conversion factor? Because I can cancel what? Moles. Then I get the mass of 1 copper, because this is of 6.02 times 10 to the 3rd of copper. So my calculation will be 63.55 divided by 6.02 times 10 to the 23rd. This whole thing in your calculator, that's grams of copper. This is how much weight is 1 single copper atom. Answer is E. Okay, I don't need to calculate, I know it is, because they are dividing 10 to the 23rd. It has to be minus 20 to the 2nd. Does it make sense, guys?
Yes.
Yeah.
Okay, again, the mass you got from the periodic table, that's where you start with, very good, but that mass has no unit. Even though that is the mass of 1 copper, but it's no unit. This question is asking you the mass in grams, so you cannot just simply add a gram. If you want to add a gram, great, you have to tell people this is the mass of 1 mole of copper. How many is 1 mole? 1 mole is 6.02 times 10 to the 23rd. So you have to divide by the total number, just like 10 people is 1,000 pounds. Then how much is 1 people? And then you use 1,000 pounds divided by 10 people. The same. 6.02 times 10 to the 23rd copper is 63.55 grams. How much is 1? You divide by the number. You get the mass of what? Answer is E. Does it make sense, guys?
Yes.
Yes.
Perfect. Next. Okay, next. After we understand what is mole and what is grams and what's the relation grams and mole, let's take a look at deep or more details of a molecule and apply the concept of moles in it. We know when we have a molecule or we have a formula, the subscripts tells us the number of atoms of each element. For example, N2O4, the example given here. What does N2O4 mean? Means in one molecule of N2O4, it has 2 nitrogen and 4 oxygen atoms. That's what the subscript mean, 2 and 4 mean. Now, remember we said earlier, the mole is a unit of number. So if a molecule has 2 nitrogen, 4 oxygen atoms, we can also say one mole of this molecule have 2 moles of nitrogen and 4 moles of oxygen. How do we get that? I multiply 6.02 times 10 to the 23rd on everybody. Again, if one molecule has 2 nitrogen, 4 oxygen, then 1 mole of the molecule will have 2 moles of nitrogen and 4 moles of oxygen. Why? Because mole is a number. Mole is a unit of number. So now we have a broader view of the subscripts. The subscripts not only tell us how many atoms of each element is in the formula, it also tells us how many moles of the atoms if we have 1 mole of the molecule. If you feel this a little weird, think about it. One person has 2 arms. A mole of person will have how many arms? 2 moles of arms. The same. Why? Because mole is a number. Or let's do it a little smaller. 1 person, 2 arms. A dozen person, how many dozens of arms? 2 dozen of arms. Why? Because 1 person, 2 arms. If you could understand 1 dozen person, 2 dozens of arms, you could understand 1 mole person is 2 moles of arms. Then you understand 1 mole of N2O4 has 2 moles of N, 4 moles of O. Why? Because that's how the subscript is telling us. Does it make sense, everyone?
Yeah.
That's how the subscripts can be used. That's how we apply the concept of moles. Why we need that? Because remember, moles is related to grams. In our lab, we're real working on the chemicals. We have to work in a mass unit. So here is the idea. The subscripts, again, it does tell you the number of atoms for each 1 single molecule. It also tells you the number of moles for 1 mole of molecule. For example, this is the caffeine formula, C8H10N4O2. That means 1 mole of caffeine contains 8 moles of carbon, 10 moles of hydrogen, 4 moles of nitrogen, and 2 moles of oxygen. Why? Because those are the numbers from the subscript. That's what the subscript tells us. If you understand, yes.
Why is it C8H10N4O2 and not a lower ratio? Because you could divide all of this by 2 to create a smaller ratio.
Because caffeine is not an ionic compound. owning the caffeine is like a molecule. It's like a person. It does have 8 in there. It does have 10 in there. You cannot reduce because it doesn't have a molecule, intact molecule. Ionic compound, because it doesn't have a molecule. The ionic compound is a network. That's why we reduce to the smallest ratio.
Okay, thank you.
Yes, these are molecules. These are molecular compounds. They're real molecules. So you cannot reduce. Okay. Next, if you understand the concept, let's calculate practice. Like I said, this whole chapter is all about calculations. Your next quiz, by the way, maybe 1 or 2 multiple choice. The rest of it is all show me your work and take a picture and send it to me. Question here, asking how many moles of carbon atoms and how many moles of carbon atoms and how many hydrogen atoms are present in 2.5 moles of ethane. So there are 2 questions. The first question is easy. The second question is one extra step. So let's take a look one and another. The first question asks you, how many moles of carbon atoms? We know each 1 mole of C2H6 has how many carbon atoms? 1 mole has how many? Guys?
How many atoms or how many moles?
How many moles? 1 mole of C2H6. How many carbon atoms? How many moles of carbon atoms?
2.
2.
2 moles. Okay, very good. 2 moles of carbon atoms. So we have an equivalence now. See, if I have an equivalence, I can convert 2 conversion factors. Then let's start with the given 2.5 moles of C2H6. Multiply again, guys. Take a look. I always start the one I'm giving and multiply something. What do I multiply with? I multiply 1 mole C2H6, 2 mole of carbon. How do I get it? From here. 1 mole C2H6, 2 moles of carbon. I put 1 mole of C2H6 in the bottom. Why? Because I want to cancel moles of C2H6. So the calculation is 2.5 times 2 equals to 5.0 moles of carbon. Do you guys see that, everyone? You guys see that?
Yeah.
Yes.
Very good. Now let's move on to the next question, which, like I said, it takes 1 extra step. Next question doesn't ask you how many moles of hydrogen. It asks you how many hydrogen atoms. How many means what? They need you to count now. They need to count the real number, just like how many people, 10 people, 20 people. They're asking how many moles of people. So that means this question needs 1 extra step for the second question for hydrogen. But again, guys, keep that in mind. We always start with the given. Okay, form a good habit. No brainer, start with the given. What is the given? 2.5 moles of C2H6. If I wanted to know how many hydrogen, I need to think about the number in real is connected to what? To moles. Why? Because 1 mole is how many, guys? 1 mole is how many?
6.02 times 10 to the 23.
6.02 times 10 to the 23rd. So we know the number is related to moles. So if I wanted to know the number, I want to know how many moles of hydrogen first. Then my first step is to convert the moles of C2H6 to moles of hydrogen. Tell me, 1 mole of C2H6, how many moles of hydrogen? How many moles of hydrogen?
6.
6 moles of hydrogen. Very good. Why do I need in moles? Because mole is related to numbers. They're asking number. So I can't get number first. I have to get moles first. Take a look, guys. Let me use a different color pen. Moles of this one cancel. I get what? I get moles of hydrogen. But that's still moles of hydrogen. The question asks you how many hydrogen. So I further multiply. 1 mole hydrogen is how many? 6.22 times 10 to the 23rd. I put moles on the bottom now. Why? Because I want to cancel moles now. I want to get the real number. So moles of hydrogen canceled. The calculation will be 2.6 and 2.5 times 6 times 6.02 times 10 to the 23rd. Everything in your calculator, this will tell you 15 times 6.02, 9.0 times 10 to the 24th hydrogen atoms. Okay, guys, I'll give you a couple minutes to digest and let me know if you have any questions. The first one, converting the moles of this guy to the moles of carbon. How do we get the relation? Formula, because one has 2 moles of carbon. 1 mole of C2H is 2 moles of carbon. The second one, they're not asking the moles of hydrogen. They're asking the number of hydrogen. But the number is related by moles. 1 mole is 6.02 times 10 to the 23rd. So I first still need to find out the moles of hydrogen. How do we get the moles of hydrogen? 1 mole of this guy has 6 moles of hydrogen. How do we know 6? Because it's C2H6. Then I further multiply a second conversion factor, cancel the moles to get the numbers. Does it make sense, guys? Please let me know. Please feel free to ask. I can slow down, but you have to, that means questions. Don't be shy. Like I said, chapter 6 and 7 all calculations. You have to understand everything before we move on, please.
I think I understand.
Okay, and by the way, guys, like I said, the whole chapter, the calculation, the most part is your work. Do not give me an answer. I need to see your work. That means if I have a question like this, if you show me until my green line, even your final answer is wrong, you get 90% or above credits. If a 10-point question, you get 9 or more than that. So that means even your calculator messes up. You show me all the green line steps. Show me the conversion factor, show me cancel, and show me how do you put numbers in your calculator. Even you messed up with the inputting your fingers, final answer is wrong, it's fine. That's not chemistry, that's math, that's your calculator. All I want to know is you understand the concept from chemistry. So please, guys, show me the answer, show me the work. It's more important than show me an answer. If it is not a multiple choice question. Okay, I will try my best to specify, guys, on a question title, show me your work. Okay, show me your work. If I forgot, you can always ask. Multiple choice, you never need to show me your work, by the way. Okay, next. How many moles of carbon atoms, hydrogen atoms, and oxygen atoms are present in 1 mole of aspirin? What is the answer? How many moles of carbon atoms, hydrogen atoms, and oxygen atoms are present in 1 mole of aspirin?
A.
A, very good. 9, 8, and 4 moles, because that's where we got from where? The formula. Sorry, where's the red one? The formula. Very good. 1 mole aspirin, 9 moles of carbon, 8 moles of hydrogen, 4 moles of oxygen. Next question. Still 1 mole of aspirin. They ask you how many grams of carbon is present. You may say, what the heck? I don't even know where to start. Here I'm going to show you when you see a question, how do you start with? How do you think when you have a question? How do you think? What's the correct logic of when you see a question in this chapter? First, again, start with the 1 mole of aspirin, C9H8O4. Write it down, start multiplying. Now, don't move on yet. Ask yourself, what is asked? The grams of carbon is asked. The grams of carbon, we have no idea how do we get grams, but we know grams is always related to what, guys? Carbon. Grams is always related to what? For carbon, think about carbon. What is carbon? C. Grams is always related to what? Guys, carbon, C. Check your periodic table. For C, what can you find?
Is it the atomic mass?
Atomic mass, what is atomic mass?
For carbon, 12.01.
12.01, we can use 12. So that 12 in your periodic table for C tells you what? Tells you what? Don't forget what we started.
Multiply it by 9.
No. Tells you what? Again, think about what we studied at the beginning of this chapter. That 12
is how
of
many grams?
how many grams of what? Of how much carbon? Of how much carbon?
Is equal to 1 mole.
1 mole of carbon. That 12 tells us 1 mole of carbon is what? 12 grams. Do you guys agree?
Yes.
So that means if I want to know the grams of carbon, I want to know the moles of carbon first. Can I know the moles of carbon? Of course I know, because 1 mole as aspirin, how many moles of carbon? 9 moles of carbon. You guys did it in the multiple choice already. 1 mole aspirin, 9 moles of carbon. And I also know 1 mole of carbon is 12 grams. So all things connected. So here's the work. 1 mole of aspirin, multiply 1 mole of aspirin. How many moles of carbon? 9 moles of carbon. Further multiply 1 mole of carbon. How many grams, guys? 12 grams. Done. See? Let me use a different color pen. Moles of aspirin. Moles of aspirin canceled. Moles of carbon. Moles of carbon canceled. I get what? I get grams of carbon. That's what we want. Grams of carbon. So the calculation is 1 times 9 times 12 divided by 1. I don't need it. So in your calculator, grams of carbon equals to 108 grams of carbon. Take a look, guys. Again, I don't want to move too fast, but you have to ask me questions. Which part do you don't understand, and how? Which part do you have to like remedy? Guys, anybody? Questions, please? No questions? Okay. So far, we have seen all these initial types of questions, and that can be summarized by the next 3 pictures. We're basically converting 3 things. I mean, between 3 groups. First group is the number of something versus the mole of something. If we want to convert the number and moles, what is the conversion factor? 1 mole equals to 6.02 times 10 to the 23rd. So this is the first conversion factor. If the question asks you to convert between the number, I mean real number, and mole, 1 mole is 6.02 times 10 to the 23rd. That's the conversion factor you need to use. Again, you have two conversion factors, depends on which one you need to convert to. Next, if I want to convert the grams of something to the moles of something, what conversion factor do I use? Molar mass. What is molar mass? Grams per mole. What does gram per mole mean? Means 1 mole equals to how many grams? Sorry, how many grams? So molar mass will tell us the relation between mole and grams. 1 mole, how many grams? How do we know the molar mass? By the way, let me ask one of you, Olivia, can you tell me how do we get the molar mass? How do I know the molar mass?
Hold on. It's the atomic mass.
It's the atomic mass.
Mm-hmm.
Now, what about a molecule? What about a molecule like CO2 or NO2? What about a molecule? They're not atoms. How do we know the how do we know the molar mass? Anyone?
The formula mass?
Numerically equal to what? Either the atomic mass or formula mass. Numerically equal. Keep in mind, formula mass or atomic mass have no unit, but molar mass has a unit, grams per mole. You got the grams per mole from these two numbers, but keep in mind the units are different. We only say they're numerically equal. They're numerically equal. And number 3 is the mole of something. Convert between the moles of a compound or moles of formula with the moles of the element within a compound. And that is from the formula and the subscripts. Just like we did C2H6, the formula will tell us 1 mole of this guy actually has 2 moles of carbon, 6 moles of hydrogen. From the subscripts, we can tell the number of moles of compound versus the number of moles of the element. So these are the 3 major calculations of the first part of chapter 6. Again, you may need multiple steps, but these are the conversion factors you think about. Think about what 2 versions you need to convert. If you need to convert a moles and number, 6.02 times 10 to the 10 is 1 mole. If you want to convert grams and mole, again, grams and mole is the one you use most of the time. What do we use? Molar mass. How do we get molar mass? Numerically equal to atomic mass or formula mass. This is actually the one you use most. Actually, this one will be used in the second part as well. And third one is, of course, within a formula, from the subscripts, we can tell the moles of the elements versus the moles of a compound. Okay? Any questions, guys? All right, let's keep moving. Okay, sorry. Normally in a class, I'll let you guys practice in yourself and I walk around, but unfortunately we can't. So I'm showing you all these calculations together and try to work with you. Like I said, this chapter is all calculation. You can see that I don't even use other examples, all calculation. I want to show you how to carry out these calculations. The formula of aspirin is again C9H8O4. They ask you to calculate the number of molecules in 0.325 grams of aspirin. We were given 0.325 grams of aspirin, C9H8O4. Okay, take a look what I'm doing now. I write down the given, multiply, then I stop. I think backwards. What is the question asking for, guys?
Number of molecules.
What is it? Number of molecules, the real count. The number is related to what? Number is related to what?
A mole?
Moles, right? Take a look, guys. Don't think that what I'm showing here is nothing. This is, we're using these. The number, take a look. Number of something is related to what? To moles. Who relates these two guys? This guy relates to these two guys. So that means if I wanted to know the number, I need to know what? I need to know what? Moles. Do I know moles yet? No, I only know what? Grams. The question only gave me grams. So I still need to change grams to moles because I want to know moles in order to know numbers. Does it make sense? Do you guys still on the thinking now? First,
Yes.
they're asking number. How do I know the number? From moles. But I'm not given moles. I'm given grams. That means I need to convert grams to where? To moles. How do we count grams to moles? Take a look. Moles and what? Grams. What do I use? Molar mass is the one I use. So that means this question I need to use two conversion factor. Molar mass as a conversion factor and 1.02 times 1 mole equals to 6.02 times 10 to the 23rd is another conversion factor. So let's start now. Okay, once we analyze backwards, we can go forward. Grams, multiply, aspirin. What's the molar mass for aspirin? I forgot. Anybody remember what's the molar mass for aspirin? Or can you do a math for me?
I got 180.17.
180.2. Okay, let's see. 180. Okay. Is that right? Is that what you got?
Yeah.
Okay. So 180 point, I'm sorry?
I got 180.2.
What? Okay,
He
thank you.
said, yeah.
180.2. 180.2 means what? 182 means 180.2 grams is what? Is 1 mole. 1 mole is 180.2 grams. Of course, we're talking about aspirin. Why I put the grams on the bottom? Because I want to cancel what? Grams to get moles. Now I have moles. Then I further multiply 1 mole is 6.02 times 10 to the 23rd. 1 mole cancel. Question is done. All I need is put the number in your calculator. 0.325 times 6.02 times 10 to the 23rd, parenthesis, divide by 180.2. 0.325 times 6.02 divided by 180.2. I got 1.09 times 10 to the 21st aspirin molecules. Answer is B. And by the way, guys, if you want some tricks about the calculation, when you do the calculation, only use these three numbers, not the exponent. Leave the 10 to the 23rd behind. So basically what it's, sorry, shoot. How do I get it back? How do I get it back? I hate myself. Let's do it again. 0.325 grams times 180.2 grams, 1 mole times 1 mole, 6.02 times 10 to the 23rd. Grams canceled, moles and moles canceled. I got 0.325 times 6.02 times 10 to the 23rd over 180.2. Again, guys, what I did is only use these three numbers. I leave the exponent behind in my calculator. So what I actually got is 0.0109 times 10 to the 23rd. Again, don't lose it. You just don't use it in your calculator. So this is what I have from a calculator. Then you move the decimal to the right by 2 places. You got 1.09 times 10 to the 21st because you need decrease the exponent by 2. You moved it to the right, you decrease the exponent by 2. Anyway, whichever way works for you in the calculator, you still need the final answer to give me the to get the last 10% of credits in order to answer it to get a full credit. But like I said, if you show me the green underlying part, you got 90% of credit already. Does it make sense, guys?
Yes.
All
Yes.
right. Let's move on. Next question. Okay, next question. We'll do the rest 3 if we have time today. If not, you can use that as your practice. Those are like a multiple choice, but this is one I always want to practice with you in front of you. And by the way, guys, take a look. I think we earlier talked about how many molecules, how small the molecules are. You can think of 1 tablet of aspirin is around 0.3 grams. And for that amount of aspirin, you can see how many aspirin molecules you have. 10 to the 21st. That's how many. We don't even have a word for that. A trillium is 10 to the 12th. A billion is 10 to the 9th. A trillion is 10 to the 12th. I think the world population is what? Anybody quick search world population is 14 what? Or 50. World population 2020. World population is 7.8 times 10 to the 9th. So 7.8 billion. That's world population. And you can see that this is the 10 to the 21st. How many molecules? When it comes to molecule, it's a lot. Okay, the number is beyond our imagination. That's why we have to use the concept of moles. Okay, next on the moles. So this question, how many grams of nitrogen are present in 0.1 grams sample of caffeine? The formula of caffeine is CHH18F144. So we were given 0.1 grams of caffeine, CHH10N4O2. Multiply. Again, take a look, guys. I want you to show me this to form your habit of working questions. I mean, you don't really need my way, but for most of you, I strongly recommend you to follow this way. Okay, if you have your method, that's fine. In a test, by all means, show me your work. As long as I see your work is correct, doesn't have to be my way, but I want you to show you guys a good habit. For most of you, this will be useful for solving any chemical questions. This is what we're given, 0.1 grams of caffeine. Multiply, I stop. So I ask backwards. The question asks us how many grams of nitrogen? Nitrogen, N. Can anybody tell me? If I want to know how many grams of nitrogen, what unit do I need to know? If I want to know grams of nitrogen, what unit do I need to know?
How much the atomic mass of nitrogen is equal to 1 mole?
You answer the question correct, but not in the way I want you to. I mean, that's correct. Sorry. I mean, I don't want to be too picky. You said the atomic mass of nitrogen is 14, right? That 14 tells us what? 1 mole of nitrogen is what?
14.
14 grams. Don't lose the grams.
Okay.
Not 14 grams. So that means if I want to know how many grams of nitrogen, I need to know what? I mean, let me write it down backwards. If I want to know grams of nitrogen, I need to know what? Moles of nitrogen. Because nitrogen is 14 grams per mole. Make sense, guys? I'm doing backwards. This is a backwards, even though the arrow is, let me do it backwards this way. If I want to know grams of nitrogen, I do backwards. I need to know the moles of nitrogen. 14 grams per mole. That's done. I'm moving backwards one more step. I want to know moles of nitrogen. How do I know the moles of nitrogen? Nitrogen is what? Is an element in caffeine. So the moles of nitrogen is related to the moles of what? Caffeine. Moles of caffeine. What's the relation, guys? What's the relation between moles of caffeine and moles of nitrogen? Can anybody tell me?
There are 4 moles of nitrogen and 1 mole of caffeine.
Perfect. From the formula, we know that. We look at the formula, one caffeine is 4 nitrogen. So 1 mole of caffeine is 4 moles of nitrogen for 1 mole of caffeine. See, I'm moving forwards one more. Now, I want to know mole of caffeine. Do I have the moles of caffeine? I don't. The question only gives me grams of caffeine. So how do I convert the moles of caffeine to grams of caffeine? Using what, guys? Using what? Mole and grams, using what?
The molar mass?
Molar mass. Guys, please keep checking. Here, take a look. Mole, grams, gram, mole. I use what? Molar mass. Down. See that? I looking backward, I connect all the dots. In order to know grams of nitrogen, someone said 1 mole of nitrogen is 14 grams. That's from the periodic table. So I need to know moles of nitrogen. Do I know the moles of nitrogen? Yes, because nitrogen is from caffeine. 1 mole of caffeine, 4 moles of nitrogen. So in order to know this, I need a mole of caffeine. Do I know the mole of caffeine? No, but I have the grams of caffeine. Done. Connect from the end to the beginning. So let's move forward now. Grams of caffeine multiplied by the molar mass of caffeine. What's the molar mass of caffeine, guys? I think we did an exercise earlier. What's the molar mass of caffeine? Here, 180 grams per mole. So 180 grams to mole. 180 grams of caffeine. 1 mole of caffeine. CF stands for caffeine. Does
Wait,
that make sense, guys?
is 180 grams per mole for caffeine or was it for aspirin?
This is for. I'm
I think
sorry.
it was for aspirin.
Oh, sorry. Yes, my bad. Can you guys tell me what's the molar mass for caffeine then? Can you do it? I'll do it. If you can do quicker, let me know. 96 plus 10 plus 56 plus 32. 194.
4.2.
Okay, 194. Thank you. See, I was quick. 194 caffeine, 1 mole of caffeine. Thank you, guys. It's not 180. 180 is for aspirin and caffeine. It's too much aspirin and caffeine. Now I converted grams to what? To moles. Moles of what? Moles of caffeine. So I further multiplied 1 mole of caffeine. 1 mole of caffeine is what? 4 moles of nitrogen. because we wanted a nitrogen. Finally, 1 mole of nitrogen is 14 grams of nitrogen. Sorry, it's a little crowd. I want to put them from left to right. Question is done. By now, you're down like 60%, 70%. Okay, let me use a different color pen. Grams of caffeine cancel. I have moles of caffeine. Moles of caffeine cancel. I have moles of nitrogen. Moles of nitrogen cancel with moles of nitrogen. I got grams of nitrogen. Perfect. They're asking grams of nitrogen. So in your calculator, 0.1 times 1 times 4 times 14 divided by, again, parentheses, guys. In your calculator, please do not forget a parenthesis. The reason I said you may mess up with the calculations, you forget a parenthesis. Divided by 194 times 1 times 1. Again, parenthesis. Of course, this one, either parenthesis or not, is fine for the bottom part. The final is the gram of nitrogen. So what do I got? 0.1 times 14 times 4 times 14 divided by 194 equals to 0.029 grams of nitrogen. If I calculate correct, some of you can double check.
I got the same number.
Does it make sense, guys? For everything here?
Yes.
Okay, please, like I said, you see how many practice I gave you. I'm sorry, I couldn't let you guys try first, and we're not in a class. And some of you are not that responsive, which is fine, but I haven't shown me my flow of mind. Hope you can grasp all these. There are 3 more exercises you can try. They're not as difficult as you think. You don't have to do all the calculations like these 3. Okay, there may be an easier way, but think about it. Okay, so that's all for the first part of chapter 6, and we'll continue on the second part next Tuesday, and the calculations will be more difficult. Like I said, you have to get used to all the calculations first before we can move on and up and up. And among these, this guy, between grams and mole, will be used the most, I think, especially for the second part. I'm speaking for the second part. And once you see grams and mole, keep in mind molar mass, molar mass, molar mass. What is molar mass? Grams per mole, grams per mole. How do we get grams per mole? From atomic mass or formula mass. Numerically, they're equal, but one has unit, one has no unit. Okay, this one we use most, but still you will see all kinds of questions throughout this chapter. And starting from next Tuesday, we will talk about calculation involving chemical equations. Okay, chemical equations. We'll first talk about chemical equations, then we discuss the calculation based on chemical equations. Any questions, guys, about today's topic? Mole, grams, number? All
I
right.
think I'm good.
If no more, I will stop here. See you guys next Tuesday. The